Great. Okay, ladies and gentlemen, we go now from the beater truck of Scala, beater truck of C, to the, what do I say? To the exquisite dreamliner of Scala. Okay, so I'd like you to call up your Scala command line if you have a computer here, okay? Which I would encourage. If you don't, and you could pull up to someone next to you, that's great. Everything that we see, I'll be executing it in front of you. So if you don't have a computer and you don't have someone next to you with a computer, you don't have free course, you'll see it on the screen, okay? So I'm gonna enlarge this so you can not only glimpse it on the screen, but see it on the screen. Okay? Okay, so ladies and gentlemen. Can. Good or not? Good? Okay, great. Okay, so ladies and gentlemen. Okay. Okay.
No, I'd like some lights, please.
Okay.
Sorry.
Yeah, taking notes is hard without a flashlight. Otherwise,
Not green on black.
Yeah, white on black has higher contrast.
do you want white on black?
Something else.
Okay. Okay. I will happily accommodate. Here we go. Okay. White on black. How's that?
Gotta make it a little bigger, but
Okay. Text size.
Yeah.
yeah, that's
Okay. Just so I remember it, I'm going to make it 24. Is that okay? Okay. There we go. Great. Welcome to Scala. Okay, so ladies and gentlemen, if you call up the Scala shell, you should see something like this. And I'm going to actually quit out of it. Okay, the Scala shell is a tool which you will find very handy for executing code. Scala is a compiled language. It's a language which, before you can run it, you got to run a compiler on it, which, among other things, will look for errors, which will optimize it, and output the code which you could then run. It is, however, also a language which supports a rich, interactive REPL, read, eval, print loop. It reads what you type, it evaluates it, sort of calculates it, it prints the result, and it loops. Let you do it again and again and again. Okay? We're going to be using Scala to illustrate a lot of concepts in this course, not least because Scala is one of the hottest languages out there. It's a language which is in extremely high demand right now, and which commands high salaries, very favorable job prospects, but also because Scala is an immensely practical and beautiful language. It runs atop the Java virtual machine, so you could use any Java library from Scala. I think that's fair to say, any. And it also is compatible with a wide variety of Java tools because of that. So you can use tools for profiling, for example, with Scala code, and you can use tools for sort of doing some decompilation or whatever you can use with Scala code. There's a lot of programming tools that carry over to Scala well. But Scala is a notable multi-paradigm language also. It has really good support for object-oriented programming, more cleanly, more powerfully in my mind, as we'll see, than Java. It supports, for example, beyond classes and interfaces, it supports traits, which are a very important and powerful tool for having mix-in-like functionality, mixing in functionality from more than one place into a given class. But it also has really, really rich functional programming characteristic. So it allows us to do very, very powerful things in an economy of syntax in this context. It does aspire, more than Java, it aspires to have a minimal syntax. So you have to type very little in order to execute things. And to make your life easier, it does a lot of what's called type inference. What does that mean? Anyone? What does it mean to say type inference? Yeah.
It can infer the type of the data you're giving it based on the values and other things.
That's right. So it does a pretty good job. It's imperfect, as we'll see. But it does a pretty good job figuring out what the value of something must be based on what you have given it. And you will be giving it some type information. But there's a lot of type information that in Java you would have to specify, but here you don't have to. Yes?
For example, if you put like 2 times 2,
Yeah.
it will know, or x times y, it will know that x and y have to be numbers because
That's right.
the asterisk.
Yeah, exactly. And it will figure out if you have, 2 things passed in that are integers, this whole thing returns, and you add them together, the whole thing returns an integer or what have you. Yeah. Okay, ladies and gentlemen. So here's Scala. So what we're going to do here is we are going to explore a further type of parameterization, which is type parameterization. Okay, so that's a convoluted and twisty sentence. We're exploring a different kind of parameterization of functions. We've had parameterization so that they take arguments that are values. And Scala allows us to do that. So let's define a standard little function here. Okay. Here we go. My add 10. Okay. Like my first function. Okay. My add 10. We're going to take in a value here. Let's take in a number n. And this is going to be an int, okay? And we are going to say this function computes something. And on the right-hand side, I'm going to say, what does it do? And what Scala asks you for on the right-hand side is to put an expression. And it turns out in Scala, we don't have statements in general in the classic C sense. We have expressions. What's the difference in C between a statement and an expression? Anyone say? Yeah.
I think an expression always has to return something.
Yeah, it returns a value. What's a statement do?
That's a procedure.
Okay, it does something. It's like a command. It accomplishes something, but it doesn't return a value. Think about a for statement. Think about an if statement in C, right? Does accomplish something, presumably, right? You're looping over this for some reason. You're updating some values, or you're printing something out in the if statement or something. But it's not returning a value. It's performing some action, right? And in general, ladies and gentlemen, per the slides I shared with you last time, and I want you to look over, we like to divide up our code with functions into two. Often we divide them into 2 types. On the one hand, there are functions in the mathematical sense of the word, in the sense that they compute some value, return a value. There's more to a mathematical function than that, but that's what they do. Their job in life is to compute a value. And then, classically, there are procedures. There are things that perform some action. And sometimes these are called commands, queries and commands. A query returns a value, a command does something. What we're going to see in Scala is that everything is an expression, even for constructs or expressions. And they're going to be beautiful expressions. Okay? So let's put this. My add 10. This is n plus 10. There we go. Now, let's just define a method. Okay? A method. So, we'll get into that a little bit, but this myAdd10, it's something that maps integers to what? What does it return? An integer. So we'll write that the type of this, you write this, we'll say it maps ints to ints, right? Have you seen this syntax before?
Yeah.
Mapping, where do you see that, 340?
Yeah.
Yeah, 340, okay. Good. Now, I would argue that when we did this, there was a bit of type inference that went on. Where was the sleight of hand here? Where was the type inference?
Return value.
Yeah, the return value. You noticed it figured out what the return value is. We didn't have to say, oh, the return value is an end. No, it's not. N plus 10, okay? Good enough. And now let's use it, right? My add 10 here. And let's put in 5. What should it return? 15. Okay, good. The world is sane. Minus 5? 5. Okay. Okay. Good. So here we've defined our first Scala function, yes, but it turns out it's a method in this case. It's defined with def. I'm going to define it as actually as a strict function, okay? And what I'd like to do is to do the following. Well, my add 10 function. Okay. The way in which, so in Scala, we distinguish between variables and values. When I saw this, it would be a slight exaggeration to say that I almost swooned. But it's something that I yearned for after so many years of C and Java and so on. To distinguish values from variables. Because so many times, ladies and gentlemen, in Java, we create a variable, something that can change over time, just to hold a value that is kept constant. And we have these consts, and we can use a const prefix and so on. But here in Scala, we make an actual distinction. A value is something that is immutable. It does not change. It's a name for a quantity that's computed. It's a value. It's the result of some computation. And a variable, by contrast, is something that can change over time to hold different values. Yes?
Could you move the screen up because it's really hard to see where you are down there by the back of the room?
Sure. Would you like me to? Okay. So, what's the best way to engineer this? I mean, one way to do it would be to
I can move the projector up.
something like this. You can move the projector up.
I can just move it up the screen. Yeah. I extend the table, but I can do it.
Oh, over there.
Yeah. There's a little lever I can push up on.
Really?
Yeah.
Cool. Would that be helpful?
Yeah.
Oh, yeah.
Okay.
The combination would actually work very well.
Okay. So tell you what I'd like to do. There's a time for that. I think I'd like to do it at the end of class rather than now. And with appropriate supports being offered, because there's an occupational health and safety issue here and it may be better if I stand up and injure myself than a student stands up for me and injures themselves. So we'll get her done. But for today, I'll ask you to we'll deal with it in software rather than hardware. Okay? Okay, so we're going to define here a value, and this value is going to be a function. Okay, here we go. Okay, so what is this function going to do? It's going to take in an integer, and it is going to return n plus 10. Let me, I could go and put parentheses around this if I wanted to make it really, really clear what's going on. But that's what this means. So I'm defining a value called my add function, and that value is a function. It's a function that maps from integers to integers, and you could see that here. It's a My add 10 fn is something that maps from integers to integers. Do you see that? This is, if you want to put in the precedence here, this is what that means. It's just this thing equals this function. And this little thing here is a map, right? It takes in this and it returns that. Are you comfortable with that? Okay, let's go and apply it. My add 10 fn. We give it 5 and we get back 15. Happy, happy. Great. Okay. Pretty nifty. But we ain't talking yet. Okay, so now what we're going to do is we're going to create a little collection. Yeah, indeed. Val, my array. Well, let's leave out the my. Okay. Array. Maybe we'll put in 1, 3, 5, 7. What comes next? 11. Bit of ambiguity there. 13. Thank you. Oh, yeah, I should have put 2. Thanks. What am I doing? Okay, there we go. Thank you. That would have made it less ambiguous. Okay, so we're going to do R, and we're going to now take this array. This is an array which holds those values. You notice that it's an array of end. Was there a bit of type inference going on? Yeah, I was figuring out these are ends, so it's got to be an array of end. Okay, now let's apply this function, my add 10 fn, to each element of that array. This map is going to lift this function, which takes integers and turns them into return integers. It's going to lift it to operate on arrays. So what map is going to return is an array. It's going to be an array where we've applied, just like we can apply this function to a particular number, get a number back. Here we're going to apply it conceptually to an array and get a what back? Array back.
Excuse me?
Yes?
I don't know why. Is there any difference between Scala 2.11 and 2.12? Because I couldn't decline the VA on my add 10 function.
Okay, so tell you what, I'll look over your shoulder a little bit in case there's something clear there, but
I believe this is exactly what you have over there. Give me this.
yeah, that's fine. That's fine. This is just how it's a different way it's explaining what the result is.
But when I try to use this.
Yes. Yeah.
Okay, it works.
Work. Yeah. So the different versions of Scala differ slightly in how they say. So I guess it's you're running 2.1.2?
2.1, 2.1.
Yeah, so function there is written out in a thing that says lambda. And soon enough we'll find out why. Yeah.
Let's see, right? Yeah.
Yeah.
How do you cast things? Like it says it auto infers these things, but what if you want to force it to be something? Like, for example, what if you wanted to do something with ASCII numbers as like I want to literally add 4 to this character to make it 4.
Sure. So among other things, we could do something like this: 10.to double. To double. 10.to string. 10 dot. So that's actually a string now. 10 dot. I don't know if you could do to char. That's kind of it. Oh, that's it. Why is there an extra line here? Yeah, it's a new line. 65 to char. A. Okay, 10 is the new line character. 12 is carriage return. 65 is capital A. 32 is space. I could go for a while, but I don't want to get to. There's actually a bell character too that will make. It used to make things dings. Yeah, exactly. 9 is tab. Anyway, what's that? -1. Oh. Gosh, that's interesting. Yeah, I think that might cause the Roman Empire to crash. Now, well, you mean to convert -1 to a character?
Yeah, question mark.
It's an ASCII.
Okay, that's, well, I'll be. Okay, so I'm glad the Empire didn't crash. Okay, that's great. Ladies and gentlemen, casting aside, what we're focused on here is functions. And what we've done is we've taken a function that maps ints to ints, and we've applied it to an array with this map construct, okay? We've said, okay, map these in that appropriate way. But we've done it in a rather verbose form. After all, we could have just said here something like this: n int n plus, and just to show you n plus 100, right? I don't have to give it a name. You know, there's a song, a classic song about a horse with no name. But really, if I had my druthers about the world, there'd be lots of songs about functions with no names, because they're extremely powerful. Okay, and we'll see why in coming lectures. If anyone knows about a song about a function with a name, tell me. So here we are performing a map with this. This is the function to perform on each element, and it returns back the appropriate array. Do you see that? Okay, how would we square the numbers? Yeah, n times n. Okay, great. What language does this remind you a little bit of? Of what language does this remind you?
Haskell.
Haskell, yeah. Quite similar to Haskell. And in fact, Scala, in some aspects, it was inspired by Haskell, but the desire to make something that's Haskell-like extremely practical by leveraging the whole Java ecosystem, compiling to code that can be used from Java or use Java code, and can be used with rich object-oriented concepts like subtyping, etc. We're going to see this. Okay, so here we are performing squares of each of those elements of that array successively. And again, this function gets applied to each of those elements in succession. And what map does is lift this function from operating just on an individual number, returning a number, so that it can operate on arrays. Comfortable with that idea? So we can take this function and we can apply it to array. We don't need a specific thing that's called square array as a function. Instead, we just say map and apply. Now, this is also illustrating the first encounter in this class with what's called a higher order function. Higher order in the sense of what? Yeah, it takes a function as an argument. And in general, when we say a function takes another function as an argument, or a function returns a function as an argument, or both, we call it a higher order function. Okay, so let's work on this a little bit more. I'm going to create def adder generator. And this is going to take in, we'll call it A. Take in an A. And, equals, forgive me, A. And it is going to return back a function. It's going to be a function that adds A, that takes an argument, B, and adds A to it. How would I do that? What syntax would I use here? Anyone want to try to elaborate what we've seen? So adder generator, its job in life is going to generate a function which adds. It's going to, you give adder generator a number, A, 10. It's going to return back a function whose job in life is to do what? Add 10 to things. Add 10 to whatever number is given to it.
Be int, arrow.
Yeah, okay, so int, okay, so that's, you're describing some of the type, but what it needs to take a parameter called,
Well, the int parameter.
yeah, okay, b is an int,
Yeah.
and it goes to what?
It returns
Yeah.
and a function which is
Okay, yeah, we actually don't even need to fully specify that, but let's just be clear about my thing. You've got the key idea, and it returns a plus b, right? Yeah, so you got the idea exactly, Warren. There we go. Okay, so this is a thing. It takes a, and it returns, and Warren got the key thing here. It takes an int and returns a value there. Okay, so I'm going to do adder generator of 10. What's the result? Oh, adder, not the snake, but the function. Okay, adder generator 10. Right? What does this function do? Suppose I did adder generator 10 and I gave it a 3. What would I get back? 13. Suppose I did adder generator 1 and I give it a 3. What do I get back? 4. Okay. Nifty. Okay. Okay, so now I can say adder generator 1. What am I going to see now?
An array each any argument.
Yeah, it's 1 plus. So if array was this is just 1 plus those. Grok or not? Okay. 10, what am I going to get back? 11, 12, 13, 15. Okay. Let's let that sink in for a moment. So this thing that it's giving back, this function, its job in life, if I did adder generator of 10, the function that it's giving back, what's its job in life? Add 10 to things. But I could ask an adder generator of 1 will give me back a function whose job in life is to what? Add 1 to things. Give me back a function, but the function that it gives me back is a special function. It's what I specified up there. It's this function. But I'd argue it's more textually than this function. In order for that thing that it returns, adder generator of 10, returns the function whose job in life is to add 10 to things. Adder generator of 1 returns something whose job in life is to add 1 to things. I would say that each of them, are they this function? Yes, they're the function, but with something more than just the text of this function. What distinguishes those two? Adder generator of 10, the function is returned by adder generator of 10 versus adder generator of 1. How are those different? They have different values for what?
It remembers what A is.
A. They are remembering A. They are closed with A. They are bundled with A. Yes, it's this thing here, but they're remembering their A's. In that simple world, you don't have to remember your ABCs, just your A's. Okay? And so it's remembering its A. Each of them is remembering its A. And it's bundled up with it. It's bundled up with this. Okay. So we can create functions which take functions as arguments, like map. This map takes in a function as an argument and uses that to map a collection to a new collection. But we can also take functions that return functions as return values. See that? And by returning as return values, it's not just a function, it's a function bundled together with its information. That, in short, ladies and gentlemen, that thing is, in short, a closure. It's a closure. This returns a closure. It's not just this text. It's this text with the information about any pre-variables, any variables that are in here that are not found, that are not obtained within this. And that in this case is A. So it's a closure. It bundles together, on the one hand, a function, and on the other hand, the data I should say the external data, data required by the function, okay? By that function. In this case, that external information needed for it to do its job is A. It's going to remember that. Are you comfortable with that? Okay, this is going to have profound implications. Could that happen with pointers to functions? First of all, in C, can we return a pointer to an internal function that's defined within this function in classic C? No, we can't. Could we take a function that's like my add, and it adds some number we want to tell it? Could we create something that's like an adder generator? It gives us back a point of the function that remembers its information.
You could have a pointer inside that function, but if you call adder generator again, it's going to clobber it.
It's going to clobber it. It's going to bang over it. Ladies and gentlemen, I mean, so adder generator could return could set a global variable that says, oh, you want me to do an adder generator of 10? I'll set a global variable, and then I'll return a pointer to a function which adds that global variable to things. But as soon as I call it again, that's lost. If you want that pointer of the function to depend on something, you got to pass it to it. Here, we can have functions that can remember their state, remember kind of the information they need to do their job, and we can just provide additional information. In fact, ladies and gentlemen, what we've done here is do something called currying. We've created a version of add that takes in a first argument, takes in a second argument, and adds them together. Comfortable with that? Yes.
What's the difference between, because what we're doing also is we're partially applying the functions.
Yes, that's correct.
Is there a difference between a closure and a partially applied function?
All partially applied functions are closures. Not all closures are partially applied functions. I think that's one thing I could say. Okay. Now, Scala actually provides a really nifty way. Curried mults. A, B, A times B. Curried mults of 2 gives us back, gives us back a function whose job in life is to do what? Double things. So if I give it a 3, it gives me 6. If I give it a 4, it gives me an 8. And because of certain awkwardness, difference between this partially applied function and in fact, methods and functions, I have to put this underscore to basically turn it into a function. Okay, so this is a function. Its job in life is to double things. This is a function. Its job in life is to multiply things by 10. And I can define that in a curried way, a way that incrementally takes its arguments in this sort of way by providing these multiple parameter lists. You can't do that actually with strict functions. It's something you could do with methods here in Scala. But so I can't do it with this other syntax for defining functions like this. But I can do it with defs. Okay. So actually it supports this so-called currying, which is taking an operation that needs a bunch of arguments and breaking it up into incremental things where you give each argument at a time or clusters of arguments at the same time. And it turns out that this is really, really useful for reasons we'll be seeing. So maybe you have something whose job in life is to search through a document for a certain string, and you have code which is going to apply this repeatedly each time the user wants to go to the next one. It will reapply that search. And rather than having to remember the string that's being searched for each successive one, you just create a closure that remembers the string to be searched for within the document, performs the search for that string. It's a specialized version of it. You can think of this as a specialized version of multiplication that just multiplies by 10, right? And so it allows us to create specialized versions of functions, which then we can pass around without having to drag with them all the data that ultimately they'll depend on. Some of that data is carried around by them. Maybe it sounds obvious. Maybe it sounds trivial. Maybe it sounds of questionable need. We'll see where it really plays a role. Okay, but I promised to talk with you about some type parameterization. So, ladies and gentlemen, we are going to further our work here. So we're going to take something, and this will be called my map and append. And this is going to be something which is going to, and I'm deliberately leaving something out so far. We want it at first to apply to just simplify our thinking about it so we can be clear about what it does. I'm going to have it first take in a function and two collections. Both of them are going to be purely in terms of ints right now, okay? So this function is going to be something which takes in an int, okay? And I'm going to put this in parens just so it's clear to see. It's going to take in an int, and it's going to map it to an int, okay? It's going to be a function. The first argument to my map and append is a function. It's something which takes in integers and returns integers. Are you comfortable with that idea? Next, the next thing is going to be, we're going to use arrays for now. Arrays in Scala are actually not at all privileged. In fact, I'm tempted to introduce. In fact, I'm going to. Okay. Seq1. This is going to be a sequence of ints, which could be an array, could be a vector, or some other construct. Seq2 of ints. Okay. And so let's match the parens here. Okay. This paren match that paren. That's just for that argument. It's mapping to an int. This is for that whole function. And then we've got sequence 1 being a sequence of ints, sequence 2 being a sequence of ints. What we're going to do here, what we're going to do is we are going to here return something that is going to be sequence 1 dot map. What does map take as an argument? A function. There's our function. And we're going to append it to sequence 2 maps with that function. Okay, sorry. Okay, so why isn't it happy here? Sorry? Did I forget a bracket here?
At the very end.
At the very end, thank you. No, I don't think so. Okay, let's try this. Maybe it's parsing. Hey, come on. Okay, so what's going on here? Of course, we don't get to name. We don't get to name the arguments to the function, right there. This is not up to us to name whether it's called n. Sorry. So there we go. So this is a function from ints to ints, This is a sequence, and that's a sequence. This is going to be told to us what function to use. We can't say, oh, we wanted to have a first argument called n. I mean, I don't know what I was thinking. Okay, are you comfortable with that? So its job in life is to take in a function, mapping ints to ints, take in one sequence, take in a second sequence. It's basically going to map the first sequence and append it to the map of the second sequence. Okay? So let's try that. My map and append. And we are going to pass it in a function that is going to, and watch a bit of sleight of hand here. It is going to take in an integer n and map it to n times n. Okay? And then it's going to take in an array of 1, 2, 3, and it's going to take in an array of 10, 11, array of 10, 11, 12. Okay? What should I see as a result? Do you see why that results? Yeah. Yeah, exactly. 144. Does that make sense? What if I had done 2 times n here instead? What would it give now? 2, 4, 6, 20, 22, 24. It is applying whatever function I'm giving it to each argument here, and then it's appending the results. Do you get that?
Yep.
Are you comfortable with that?
I have a question.
Yes.
What's the difference between the SEQ type and the array buffer type? Seems like if in
So arrays are an example of a sequence, but they're not the only one. So I could have said vector. Here. Vector.
You have one as an array and one as a vector. Since it was sequencing.
Good call. Mumble. Yeah.
so arrays are the superclass and these are like
No, sequences are the super type, and both arrays and vectors are subtypes. Okay, and here you're appending an array to a vector, so it becomes a vector. If we had flopped those and we had array and vector here, what do you think we'd get out? An array buffer, but yeah. Anyway, I'm not going to go into that. I'll go into some comments on that in greater detail later lecture. But you'll notice that something is going on here. By the way, could I make this a little bit more terse? Could I say something like this? Sweet. Sweet. What's going on? How come I didn't have to say this takes in an int?
Was already defined.
It actually induces it. Yeah, it's got type inference. It knows these are integers. So when we apply this thing in our definition, we're applying this function to each of these. So this has got to be something which takes an int n. And if it takes an int n as n, it's got to return a what? Int.
Didn't you define it to take it into anyways? Wouldn't it just try out and assume that n is the int right off the bat?
Could you define it to take an
No,
int?
like you define my map and append to only work on ints, right?
You said that the function maps int to int.
Yeah, this is a new definition.
Oh.
This is a new definition here. I mean, it's deducing that this maps ints.
What he means is that when you wrote my map and append, you said function maps ints to ints.
Oh, correct. Yes, you're right. Good call. Good call. Yes, I did say that. And that allowed. So it's even easier to deduce that this is ints to int. So the point is, we don't have to specify here. It's actually realizing what we're doing. But we're going to generalize this now. So we could do the same thing with double, right? My map and append double, right? Double. Here we go. Here we go. Double. Double. And there we go. And now we could apply my map. By the way, you could start typing things, and you could do autocomplete with a tab. My map and append double, tab. And we could give it n goes to 2 times n, vector 1.0, 2.0, 3.0, vector 10.11.0, 12.0, and give it that, and it gives us back this. But ladies and gentlemen, I mean, this guy I just implemented, and I'm mindful of the time here, is just another variant of what we've seen before with the integer version. So the question is, can we generalize it? And with every bit of strong respect for the outgoing president in the U.S., yes, we can. So here we go. My map and append general. We take in a type. Now we have something that's from that type T to that same type T. We take in structures that are sequences of type T, and then we apply it. And now, my map and append general, I would argue that I can actually apply this to capture both those cases before, my map and append and my map and append double, because it is parameterized by type. So let's go see that. Okay, come on. I did a tab in it. This thing is.
You have an extra
Sorry?
After map, you have an extra A.
Oh, map A. Thank you. Hey. Okay, I haven't gotten that before. My map A and append. Okay. What's going on here? Hey. App. Okay, it's exhibiting dysfunction, which is no problem. I'm gonna get out of it, and I'm gonna re-enter it. Come on. My system is exhibiting unusual load. Okay, here we go. There it is. Boom. Come on. Okay. It's working hard. Well, mumble. I don't think so. It's not thrashing. I checked. Okay, so we can now apply it to n times 2 times n. We could apply it, and then vector of 1, 2, 3, vector of 10, 11, 12, and oops, missing. Okay, now it needs to know. Okay, fine, and let's show that. Yeah, now it's happy camper. Yeah, so we could do it with that, or we could do it with double. Takes in a double. I wonder what would happen if I actually did this. It's not going to be happy with that. It needs to have these as things that are consistent. Okay, there we go. And there we go. And now it's operating on that. Ladies and gentlemen, my map and append is something that's parameterized in a classic way. It takes the data it needs to do its job and can use that data. But it is also type parameterized. It's parameterized by the type. So it can be used with different types that are consistent. So here it needs the same type for this function as is used here. And it can return that. So it can operate on doubles, it can operate on ints, it can operate on longs, etc. Okay? Type parameterization. Closures. First-class functions that are passed in, so higher order functions passed in, functions returned. It's brave new world, folks. Classic C, it's not. But it lends us to purposes more powerful yet. So next time, I'll be giving you a little exercise, and we'll continue this one. Okay? Thanks very much. If you don't have Scala working yet, see if you can apply yourself to make sure that you'll have ready access to this command line. Thank you.